Hey, welcome everyone. Welcome back to those that already attended the first session. Welcome to the day two for those that this is the first session for them. Today with us, we got Andrea Spina. He is currently the CTO at Radical Bit, a company in Milan, and his work is being focused on streaming technology, machine learning, performance boosting, and also co-authored the Flink JPML project. And actually today, Andrea will speak about development of Kafka-Powered advanced stream commerce platform. So thank you to be with us, Andrea. And well, basically, the stage is up to you. Enjoy this session.
Thank you so much, Alessandro. Welcome, everybody. Thank you for being here. I'm going to share my slides. Okay, so thank you again to be here. Today we are going to talk about Go Live, and the first thing I would like to share is how Go Live looks like.
Open the doors of your e-commerce. Reach your audience wherever they are. Go Live is an advanced stream shopping platform offering a revolutionary shopping experience. Boost your e-commerce with an interactive and direct sales tool with the highest engagement rates. Turn your viewers into players and
All right, I would like to stop here for now and let's start with the actual presentation. So my name is Andrea Spina. I'm the CDO at Radical Bit, where we leverage event stream processing features as to boost artificial intelligence tasks to our clients. And I'm here to share with you the story of Glive, that we call an advanced stream commerce platform that we developed in order to revolutionize the live streaming shopping experience. And in particular, what I'm going to do is to focus on this product that probably most of you know, which is Apache Kafka, the standard de facto streaming platform nowadays to handle with event-based architectures. We know everybody knows that the Kafka is reliable, performing, fault tolerant, and most importantly, it enables both data intensive workloads and the building of distributed and event driven architectures. And that's exactly my aim for today. So I would like to tell how we built the GoLive platform on top of Apache Kafka. And in the first section, I will share the advanced analytics framework of GoLive. And in the second final section, I will give a bit of focus on the live application building itself and how it leverages the Kafka features. But let's start with the analytics section. So this is the live analytics framework by which the clients can understand the performance of their live streaming session, and they can even compare between different live sessions. And then they have a sentiment analysis framework where they can perceive the actual user behavior and their emotions during the live. And then with the final section of conversion analytics, they can understand exactly which was the impact of a live session to the sales performance. And the first thing that I would like to mention is that we've built the analytics framework with the help of another Radical Bit product, which is a Radical Bit Helicon that enables ML tasks on a full streaming environment. And so Go Live, it uses Radical Bit Helicon, which is of course backed by Apache Kafka to build its own analytics system. Helicon, it's a Kubernetes-based framework, and it is provided with a comprehensive API layer to connect itself with the external world, and by which the users can define their complex streaming workloads logic using a codeless pipeline editor. And when they are okay with that, they can deploy these workloads to production. The core section of Helicon is a real-time MLOps platform by which the users can deploy their ML assets They can get inference, monitor the models, and they can even evolve their models in real time while the models are changing. And then we provide a DevOps-driven tool set by which we notify, we suggest to our clients when it is the right time to retrain the ML models again. And finally, we provide the first production-ready suite of special machine learning algorithms that can be trained online, so against data streams and not data sets. And we started to implement Helicon, and that's the overall architecture. As you can see, Kafka is completely the backbone. We use schema registry, consumers and producer, streams library, which is so important to us. It's also Kubernetes based. I was saying we started to implement Helicon architecture because we bumped into this definition. Continuous intelligence is a new way to see how software engineering can help business process to gather new value and new information. The idea is to connect heterogeneous business processes between each other and to convey their own data sources to the same centralized brain and applying ML and artificial intelligence on top of this heterogeneous data and gathering new value and enabling decision automation. But the business processes are not independent from each other anymore, but the decisions can be conveyed by the same data source. And at the beginning, when we started to develop Go Live, the idea was to build a vertical solution that was able to prove that continuous intelligence can be put into production. So starting from a simple example like live stream shopping, the clients could be able to add progressively new application and new use casing by attaching new data sources coming from different business processes. But then it turned out that there was room enough in the market for Go Live. So we launched it at the beginning of the year. Right now is in production, serving dozens of clients, both in Italy and in Europe. What I'm going to do now is sharing how we feed Go Live data within the platform. And after that, we have our streaming data into the platform, how we build the Go Live intelligence system using the real-time MLOps platform. So the main streaming data that Go Live generates is the clickstream data coming from the user while they are watching the live. So we monitor and we track down users' behavior and how they interact with the UI, the messages, and the reactions. And then we start to attach, as I said, new data sources like purchase data from the e-commerce, because Go Live runs internally in the e-commerce of our clients. We track down the purchase data so we can understand what was the impact of the live session on the selling performance. And then our clients can add new data sources like supply data information, either the latest marketing campaign performance to understand which was the impact of the latter to the live session and to the selling performance. So we need to deliver all this data to Kafka. And the best way with Kafka to connect the brokers, the Kafka brokers to the external world is by using consumers and producers. And on top of that, Kafka people built Kafka Connect, which is a scalable application server where source connector and sync connectors application runs and connect external system with Kafka brokers. And you can find hundreds of different connectors, both open source and enterprise connectors. And this works really great. So we started our first implementation of the Helicon API using Kafka Connect. And it turned out that we needed to require a lot of information from our users. So the user needed to log in into the platform, provide it valid credentials and connection information like connection URL to connect to a database, for example. sharing information about the data sources. So we didn't find the flexibility we were seeking for. So that we understood that for platforms like Helicon, in our opinion, a push approach was a better approach, because it increases flexibility. So the user just needs a valid account on the platform, and they can pick the client SDK as they wish, depending on the programming language they are using. And then when they are ready to push data into the platform, they can just start to push. So we did this choice. And after that, we have the data into the Kafka platform. And the next challenge was was understanding which data retention policies should we apply. And Kafka supports flexible data retention policies. So you can actually choose how much time you want to retain your data into Kafka. And since our platform abides by a Kappa architecture approach, so when you need to apply to update your business logic because there is a change, a new version, you may want to reprocess the whole history of the data. But keeping the whole history of the data into Kafka is expensive because the hardware is expensive and because bigger topics require higher rebalancing times and repartitioning times. So there are a few reasons to keep this data retention time finite, like 1 week, 3 days or so, depending on the use case. Either using changelog topics, which are with log compaction, a special kind of topic where the latest snapshot of the messages will be retained, and so the topic will be compact over time. But still, there are reasons to retain the whole history of the data. So what we can do right now is to forward the data to a tiered storage like HDFS, S3. And when it is the time to reprocess the data, we should ingest back the data within the platform, but this implies a lot of challenges. So that's the reason the multi-tiered storage feature of Apache Kafka, that in my belief will be released by the end of the year, it will be breaking through, because for the developer, the only interface will be the Kafka topic, but automatically all their data within the Kafka topic will be moved to tiered storage like S3 or Google Cloud Storage. And so that means a lot to us, but it will bring a lot of benefits because you can now rely on one single source of truth that will be Kafka. So as long as we have our data into Kafka, let's start to talk about the core of the platform. So how we build the Live intelligence platform. We need ML models, of course. And with our data science teams, we worked on different subjects. We developed object detection model because we wanted to automate the items promotion during the live. We worked on toxic messages detection because we wanted to automate the moderation. But since we are talking about analytics, the biggest work and the biggest effort has been done on sentiment analysis and natural language processing. So we built recurrent neural networks to perceive the sentiment of our users, rule-based system to grasp the actual emotion of the viewers of the live sessions, and even unsupervised models as to model the topics that are currently discussed using the chat. So we have different models, and these models are built using different ML technologies, from TensorFlow to scikit-learn. So the requirement here is having a platform that is able to put to production and to serve any kind of ML technology. But at the same time, since we are streaming based, we want low latency and high throughput predictions. So let's talk about how to shipping ML models to production. So in the past, we had different attempts like re-implementing a trained ML models with a scalable technology, either using standards like PMML, where you can different teams agree on a common standard format, so you can export the model from a technology, you can import to another one, and you can scale it to production. But probably the most used and of course probably the easiest approach that we have today is wrapping up the trained model within a container, building up the surrounding dependencies of the model, and then the model is already able to run, and then you can ship the model to production with automatic REST API, for example. And that's exactly what MLflow does. And we use MLflow, in particular, the models feature, to wrap up these trained models and to put them and to ship them to production. And the data science teams don't need to do anything than specifying which are the required dependencies. But so now we have the Docker container, or a container that can be orchestrated. But as long as we have this asset, we want to do more, because if we are orchestrating the model, for example, on top of Kubernetes, we would like to perform complex deployment strategies like canary deployment. We would like to maybe compare two different models, producing A/B testing. So the last month, we saw that there are different and new kind of MLOps platform that are DevOps driven. And we picked the Seldon Core, which is exactly going in this direction. So when you deploy a model on Seldon Core, what you have is a custom resource definition instance on top of Kubernetes. And the Seldon Core, it supports also service meshes, so you can perform that class of complex deployment strategies like canary deployment. And it supports any kind of technology. It supports MLflow as well, so it takes all the benefits from that technology. And it also has a very active community and a great documentation, in our opinion. So now we have all the ingredients for serving our ML models to production, but we need to define streaming workloads, because we want low latency predictions, but we want also to build, for the example of GoLive. In the example of GoLive, we would like to build complex business logics, streaming driven, like attaching the output of a model to the input to of the following one. And to do that in Helicon, the users can define their own streaming topologies with a codeless pipeline editor, and there they can choose which models they would like to run with this pipeline. So it will be easy to test and debug the pipeline, and when the users are okay with their work, they can ship the pipeline to production. They can deploy the pipeline and they can monitor it. So this is more or less how our MLOps stack looks like. And we have the MLOps technologies, and we have our streaming engine. So the only thing that is missing is how to connect these sections. And at the end, what we have, since we are Kubernetes driven, we have two different deployments, one for our Seldon models, which are wrapped in a Seldon deployment, and another one for our pipeline deployment, in this case, a Kafka Streams deployment. So the only thing that is missing there is the communication channel. And Seldon supports both synchronous and asynchronous communication channel, but it supports also Kafka. And of course, this is our choice. So it means that you can exchange the inference using Kafka messages. But most importantly, this means that we can leverage the high performance of Kafka and the fault tolerance behavior. So it means in terms of performance, we are only bound by the infrastructure availability that we can assign to our Kafka installation. And now I would like to focus a bit on how we should work with our streaming topologies to get low latency, high throughput. But most importantly, we have another requirement here is that, as I said, we would like to follow the evolution of the models over time within our platform because the ML models changes over time because they becomes obsolete, because there is an optimization that needs to be released, and we would like to support this evolution without downtime. So consider this predictor as an operator of a streaming topology, so a collection of computational units. And this predictor operator is chunking the input event stream data, and its main aim is to get the inference from the remote MLOps system and attaching the inference to the input event stream data, which is delivering the input feature vector. So what we do is we attach an additional stream to these operators whereby we deliver necessary metadata to make the predictor operator able to know exactly which is the current state of the remote MLOps system. So the operator will be able to query the MLOps system to interpret the outcome and to attach the final inference to the input event stream that can be then forwarded to the downstreams. But if we take a careful look at this operator, what we have here is a join. So what's the right way to perform this kind of join in a distributed fashion? So if you pick the classic join, inner join approach, a, a good performing join is driven by the very high number of keys. So driven by this number, we can evenly distribute our workloads to our parallel tasks. But in this case, the number of keys is bound by the number of the models that we have, so the model IDs. And they can, even though they can be hundreds, we will have a so much bigger number of event stream data, and they will probably seek in a moment in time the same model or the same subset of models. So that means you will probably stress one particular task and you are not scaling so well. So the right approach here is to use the so-called map side join approach, either called broadcasting pattern, whereby we take our control stream and we broadcast the messages to all the parallel tasks together. So we replicate the message to all the parallel tasks so that each predictor parallel task knows exactly the same big picture of our remote MLOps system. So each task will be able to serve the event streams in the same way. And that implies that we don't need to shuffle our event stream, input event stream anymore, because each chunk of data can be delivered to whatever parallel task, and each task will be able to grab the prediction for the remote MLOps system, attaching that to the event stream, and deliver it to the downstream. So we are done with our go live intelligence system by leveraging Apache Kafka features and the Helicon real-time MLOps platform. And now in my second section, I would like to share how we use Kafka as well to build our go live distributed application. So this is more or less how the overall architecture looks like. So it's an hybrid architecture because we have microservices, but we do leverage also cloud product like Google Cloud Firestore, which is a NoSQL document database provided by Google. And it provides great performance. It's so easy to store data within Firestore, and it's moreover more easy to query the data in real time. And we decided to employ Firestore because we were able in this way to give quick feedbacks to our client applications. Also, Go Live is a Kubernetes-based system, and of course, the backbone here again is Apache Kafka. And in this case, I would like to focus a bit the Kafka Streams library because we made a strong usage of it in our microservice building. So Kafka Streams is a library, is not a streaming engine because we already have the streaming engine, which are the Kafka brokers. So it means it's a library that allows to build client applications that embed streaming workloads. And that means you can develop this client application wherever you want on whatever service. And that means also that this strategy is super Kubernetes friendly because the Kafka Streams application in this way becomes stateless. So with a deployment, you can replicate your workloads and it will be so easy to orchestrate with Kubernetes Kafka Streams application. But still, we know that streaming workloads are stateful computation. So how does Kafka Streams model the state? Using the state store mechanism. State store is a state modeled as a key value database, and it is a distributed and sharded database. So each replica of our app will have a piece of the state of the particular state. And the secret here is that the state store is backed by another Kafka topic, which is a changelog topic with log compaction. And that means our state store has its own information within the topic. So for each key, the changelog topic will retain the latest value information for that particular key. And that means if the app restarts and so it loses its state, it will restore the state store starting from the changelog topic, as the event sourcing application do. And on top of that, we have interactive queries with Kafka Streams, whereby remote applications can query whatever replica of your streaming application and can ask whatever key of this store. So if we need to grab this information, we can query from a remote service, and each replica will be able to retrieve the right key for the query. And that's very important because it enables not only classic asynchronous microservices building, so that you can enable microservices that work in isolation. And even if you have part of your infrastructure which is out of order, a service can still run, it can still be available because it owns all the necessary information to keep it running. But the most interesting thing here, in my opinion, and it is what I would like to share, is with Apache Kafka, you can even build functional requirement directly. This is the go live example of a poll session. So like we have in this platform, the moderators stands for a poll. So the users will answer to a question, and then at some point you will have the results, and they will be real-time results. Okay, so but this task can be data intensive if you have hundreds of different live streams running at the same time, and do with multiple polls for each live show. So we decided to build this feature exactly by using Kafka streams at the same time. So when the client users performing their vote, assign their vote to the poll, so this information will be delivered to our backend service, and our replicated backend service will forward this information to a rough input topic. And then what we do is we feed this input topic to a Kafka Streams application, stateful application, where the final results of the poll are computed, and these votes can be partitioned across different polls, across different live show, across different tenants. And when we compute the results, we sync back the results to another output Kafka topic. And finally, what we do is we grab the information with a consumer from the backend service, and we forward the results to our client application by using Google Cloud Firestore. And the important thing here is that we can embed these workload within the backend service itself if we want. And this backend workflow can be scaled using Kubernetes accordingly with the prior service in a very easy way, because the states are back to Kafka, and the computational requirements are just driven by how you orchestrate your deployment using Kubernetes. So, as to wrap up, we are going straight ahead to the conclusion. Today, I talked about Go Live and how we built this system on top of Apache Kafka, both for achieving data-intensive tasks and using consumers and producer and streaming applications to build the Go Live intelligence system. And we proved that Apache Kafka can be the backbone also for a real-time MLOps platform. And the other way, I shown that with Apache Kafka, we can build actual application, distributed web application, and we can even build functional requirements with Apache Kafka. So, as to conclude, I would like to show how Go Live looks like in the world picture.
Open the doors of your e-commerce. Reach your audience wherever they are. Go Live is an advanced stream shopping platform offering a revolutionary shopping experience. Boost your e-commerce with an interactive and direct sales tool with the highest engagement rates. Turn your viewers into players and find out what they think. Stay close to your audience all the time, keeping the live show always on during the entire shopping experience, and giving the chance to replay the video on demand. Joining a live show is easy. Just accept the invite. Promote the live show through the marketing channels you prefer. Customize the interface to showcase your products in a new and innovative way. The versatility of the platform allows you to create a closer bond with your audience. Engage your audience with original formats. Turn your live shopping into an interactive show. Go Live is the first platform that blends live stream shopping with real-time analytics and AI. Find out in real time which products your audience loves. Predict the purchasing behavior of your viewers thanks to artificial intelligence. Go Live. Make your e-commerce stand out.
So, I'm done. Thank you so much for listening. Happy to answer to your question if there are any.
Thank you very much. Thank you very much, Andrea. It was really great speech. And definitely hope that people will have a question for you because that was really interesting. Okay, let's see if there's any question. In the meantime, I have a question for you, just out of curiosity. You mentioned two major tools, MLflow and Seldon Core, as part of your infrastructure. And I was mostly curious, how do you select them, and actually if you evaluated any other tools in the selection? Because I know, for example, MLflow is very well known in the data scientist platform. So I was just curious how to know more.
Yeah, that's a good question. So we started with the MLflow itself a couple of years ago, 1 year and a half ago probably, and it works great. So it was easy to choose it. But then with the development of the platform, we understood that we needed such additional tools to exploit also the Kubernetes power, no?
Yeah.
And so we started to seek for this DevOps-driven MLOps platform, and we compared in particular Seldon Core and KF Serving.
Yeah.
And that's an interesting point because we were in love with KF serving as well, which is a project by Google. Actually,
Yeah.
it's a bigger community, and it has also scale to zero feature because it's backed by Knative, so
Yeah.
it's so sexy. But it seldom sounded more ready at our side. But at the same time, there is a shared effort between the Seldon community and KF
Yeah.
serving community. They are working on some common task, and they are also building one abstraction layer over the technologies, abstraction API layer. So that means with one single SDK, we will be able to run both Seldon models and KF serving models without paying so much pain into the supporting two different technologies. So we are confident that in the next year we will be able to use both.
Yep. Well, thank you for that. I don't see any question. People are shy. Probably it's just still morning. Don't be shy, people. I'll pose you probably a stupid question while we're waiting. Based on your experience, you're very well fond of Kafka, especially. So I was curious if any one of our attendees want to learn more about Kafka or learn or starting with the technology you described it. What would be your advice for these people?
So I would say definitely putting our hands dirty. And at the same time, I believe that the Kafka documentation, the Java docs especially, are so well documented. And so I suggest to read the Java docs of Apache Kafka, starting from the consumers and the producers. And then if someone wants to have a deeper look at the technology, there is this Kafka Definitive Guide, which is a book. And it's very comprehensive book. It touches pretty all the topics, even infrastructure topics, scalability, fault tolerance. And I would start from those sources, yes.
Yeah, thank you for that.
Yeah.
Okay, I don't see any questions. I still see a lot of people actually watching us. Don't be scared, we are just two Italians, I promise. So just in case. Okay, I don't see any more questions. Just a reminder for everyone that is watching, if you have any question for Andrea, even after the session, you can use the Pine platform. You simply point yourself to the Andrea profiles and you will be able actually to send him a question there. I think the presentation will be shared as well with all the attendees. So don't stop yourself actually to posing question even after the session.
I would be so happy to answer if there are any questions.
Definitely. I will probably one of those people that actually will set your question for sure. Because definitely your platform sounds really, really, really great. I have to admit, it sounds really great.
Thank you.
Okay, I see we don't have question, neither comments in the public chat. So I think we can close the session here if you want.
Okay.
And I basically enjoy the rest of the day, everyone. Thank you again for your great time, your great presentation, Andrea. It was really, 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 really appreciated.
Thank you so much, everybody, for listening, and see you virtually in the platform.
Yep. Thank you.
Bye-bye.
Bye. Okay, you need to click on the end session, I think.
Yeah, bye-bye. Oh, 10 seconds countdown.
Yeah, it seems like we still have the countdown.
Yeah. Goodbye.
Oh.